Hi guys, welcome to Piece of Code and welcome to this video. In this video, we are going to see a summary of what we learned in this chapter 2, which is operator and statements, and then we're going to see some expected questions which will come from this particular chapter. So let's get on with it. Okay, so let me just present the screen. Okay, all right, let's move on. So what is the summary and what is the main takeaway from this particular chapter? The first point is that be able to write code that uses Java operators, right? So this chapter covered a wide variety of operator symbols, and if you want, you can go back and review them several times so that you are familiar with them throughout the rest of this particular exam, whatever you are going through, right? Exam preparation. You can go through my videos again and again if you want. Be able to recognize which operators are associated with which data type. So some operators, right, may be applied only to a numeric primitives and some only to Boolean values, right? And we have learned this again and again, and some only to objects also. It is important that you notice when an operator and operands, right, are mismatched, and this issue is likely to come up in a couple of exam questions because they try to trick you by changing the data type of the operands with certain operators, right? Understand Java operator precedence, very important to understand. I have already showed you a table, right? So you have to understand Java operator precedence, very important. Be able to write code that uses parentheses to override operator precedence, right? So we have already seen, right, if there is an expression like x plus y, right, and it is in brackets, and then we have into y minus z or something like that. Basically you need to evaluate the brackets first, and then you will do this into according to your precedence, right? So you have to follow this rule that your brackets or parentheses override your operator precedence. Understand if and switch decision control statements, very important. Basically understand how if and else is used, then switch statements. We have also learned about that fall through effect, right? When there is no break in a particular case, basically the subsequent cases are executed until a break statement is encountered. That's what we saw. Understand loop statements, right? Very important. Know the syntactical structure of all loops, including while, do while, for. Each loop has its special properties and structures, right? Also be familiar with the enhanced for each loop. Nonetheless, when some questions may come from the collection framework which will use the for each loop, right? So make sure you give a good read on that particular topic. Understand how break and continue can change the flow control. Know how to change the flow control within a statement by applying a break or a continue statement. Also know which control statements can accept break statements and which can accept continue statements. Basically you can use break in loops and also in switch statements, but when we come to continue, you can only use it in loops. And remember, you can also use optional labels, very handy when you want to break out of the outer loop, right? It's very cool in that way, and some question may come from that. Yeah, that's it, right? So basically this is all about the summary. Now let us see some questions, and let us see how some questions may come in the exam, and let us discuss a little bit in this particular chapter, right? Let us move on. So first question is basically very simple to answer. Basically, if you look at this question, which of the following Java operators can be used with Boolean variables, right? So here are the options. You can pause the video and answer the question. Okay, so the answers are A and D. So this will be the answer and this will be the answer. Why is that? So just understand the question first. Which of the following Java operators can be used with Boolean variables? Boolean, what I'm saying. So the equals or the double equals operator, right? You can use with Booleans, right? Because you can compare true equals to false, right? And this will basically give a false value, something like that. You can use it with Boolean variables. It's possible to use this double equals to with Boolean variables. Not is also possible if you have a true value, for example, you can do a not and it will be a false, right? Because it inverses whatever result you get, right? And other things, percentile is arithmetic, relational, it is used with numeric things, right? Less than equals to, and then we have a plus and we have a minus. I think it's a minus. All right, so that will be the answers, right? Pretty simple question. Sometimes the simple question get to you, you may think that this will also be an answer because it returns a result as a boolean, but it doesn't work on boolean operands. Make sure you don't fall for that trick. Okay, what data type or types will allow the following code snippet to compile? And there is some code like byte x equals to 5, byte y equals to 10, sum z equals to x plus y, right? Pause the video, answer the question. So the answer for this thing will be A, B and D. Okay, why is that? Let us understand this thing. The value x plus y, right, is automatically promoted to int. We have learnt about this numeric promotion in our chapters, right? So int and the data types that can be promoted automatically from int will work, right? So whatever data types which can be promoted to int will only work. Options A, B, D are such data types, right? A, B, D are such data types. So option C will not work because boolean is not a numeric data type. Options E and F will not work without an explicit cast to a smaller data type, because obviously short and byte will not work, and C is a boolean, so it cannot be considered at all. So these three options can only be the answers. Cool stuff. Let us move forward. Okay, what is the output of the following application or this code what you are seeing over here? So we have this class compare values, public static void main string arguments, x equals to 0, x plus plus less than 10. So this loop kind of goes till some point, and then there is this ternary operator and then this particular message. Try to answer the question, pause it and answer the question. So the answer for this question will be F. The code will not compile because of line number 5. So it's actually if you have followed all my lectures, you'll understand that you can use this, right? Basically, but what is happening over here is that you are trying to store it in a variable which is a string type, right? String message. It can only store string type data, right? But what happens if x is, for example, less than 10, right? Then false will be the returned value, right? And a string cannot store a false value. So the compiler will complain that you're trying to store a boolean value inside a message, which is a string. So basically it will not work in this case, right? So basically if this had been this kind of stuff like system.out.println, and then this statement would have inside this system.out.println, then it would have worked, because system.out.println statement doesn't really care what kind of data you are actually trying to display on the console. It just takes the data and displays it on the console. But when you are storing the particular data in this ternary operator case, both of them should be of the same data type. If this had been this case, like two double quotations false, then there would be no issues, right? So the answer will be F, because it will not compile because of line number 5. Very simple to understand. We have already discussed this in detail. What change will allow the code snippet to compile? So basically this fourth question, there is some code over here. Pause it and answer it with your own. Okay, let us see the answer for this particular question. Very easy question. So the answer will be B, C, D and F. B, C, D and F. Quite a lot of number of options, right? Why is that? By B, C, D and F. Let us discuss this one by one. The code will not compile as it is, right? And it has a simple thing. It will just say lossy conversion from integer to long. Sorry, long to int, right? But the thing is, why B, C, D and F? So the value 2 into x is automatically promoted to a long and cannot be automatically stored in y. We have already seen this lossy conversion. You will get that error, which is an int value, right? Options B, C and D solve this problem by reducing the long value to an int. Simple as that. That's what we are doing, right? Because if you even convert it to a short, it will be automatically promoted to an int, so it will work, right? Option E does not solve the problem and actually makes it worse. Actually, if you see this E, it actually makes it worse. Why does it makes it worse? Because it attempts to place the value in a smaller data type. Simple as that. Option F solves the problem by increasing the data type of the assignment so that the long is allowed. Simple as that. So B, C and D and F will be the answers in this case. I skipped question number 5, I think. Okay. Alright, let us see this question. Question number 6. What will be the output of the following code snippet? So int x equals to 4 and there is some code over here, and too low, too just right and too high, that is something. Okay. Let us see this particular answer. You can pause and you can answer the question, but the answer to this question is pretty simple. It will be F. The code will not compile because of line number 7. So due to line number 7 it will not compile, and it is pretty simple why it is the case, because you have two else cases over here, and if you have a if over here and you can only have one else statement. Now instead of else you can have multiple else ifs, right? You can have n number of else ifs, but you can only have one else statement. That is the only thing. It's pretty simple, right? Now question number 7. This is also a simple question, and it is kind of related to the previous one question that we learned in that particular case, where the false was a wrong answer, right? In this case it is pretty simple. You can pause and answer the question. In this case the answer will be D, which is 8. Why is that? How is it possible? Let us see this thing. As you have learned in the ternary operator, right, although parentheses are not required, they do greatly increase the code readability. Now when you see this thing, don't panic. This is not wrong, but it is kind of a bad readability, you can say, but the examiner will try to trick you. So basically how we can write this to increase the readability. If you cannot understand it like that, let me rewrite this in a pretty simple manner. So system.out.println, we can write it in this manner. So x greater than 2, this is the condition, right? And then we have a question mark, and we have x less than 4 over here. That is the first. So we have this thing. We have x less than 4, right? And inside here we have another question mark, and then we have 10 colon 8, right? And then colon 7. So if you see in this case, this is the first condition. You can just name it as condition 1, and basically for this condition 1 has two outcomes. This is the true outcome and this is the false outcome, right? This is the true outcome, this is the false outcome, because this is the thing. Because now I have given the parenthesis, now you can understand, because after the question mark this is the whole one expression, which is the true condition, true outcome. Now x is greater than 2, right, which is true, right, because x is 5 in this case. So it will go inside the true outcome, and inside this true outcome there is another ternary operation which says x less than 4, which is not true. So it will go in the false outcome of your this expression that you have over here. So that's why the answer is 8. So it's kind of a little tricky because there are no parentheses over here, but still please pay attention in the exam. Question number 8. Question number 8. What is the output of the following code snippet? Very simple question, and the answer is basically B, and there is nothing to that much understand, but this example can be a little bit tricky if you do not know the concepts. If you see the second assignment operator, which is embedded, right, the second assignment operator, embedded in line number 5, if you see this thing, right, what it happens, it's a very simple thing, right, but that is not a double equals to operator, that is basically an assignment operator which is embedded there. That expression z equals to false, assign the value false to z and returns false for the entire expression, because that's what it's doing, right? Since y does not equal to 10, the left hand side returns true, therefore the exclusive OR of the entire operation assigned to x is true, right? So that is why here we can say that it is a true, because it has been assigned to x. Now z is false, that is why the z is false over here, and y value is 20, so it is 20. Nothing much to discuss. The only thing that you need to see is this particular operation that is happening over here. Don't get confused it with the double equals to operator, but it's a single equals to, it's just assignment. Even though it is assigned to the z, z itself becomes false and this expression returns false. This expression returns false completely. That is why the answer is P. But it's a very simple question if you know that particular concept. Now, how many times will the following code print hello world? It's very easy actually. Very easy. Now, the answer is very simple. The answer is actually F. The code contains an infinite loop and does not terminate. Why is that? Why does the code contains an infinite loop and does not terminate? In this example, the update statement of the for loop is missing. If you see this thing, the update statement of the for loop is missing. Now, which is fine as the statement is optional, because all of the statements and actually for is optional. You can write a loop like for like this, you can write a loop like this, but this itself is an infinite loop, right? This is also possible. So the option D is incorrect in this case, because there is no compilation issues, as we can omit one of the statements in for, because it is optional, right? The expression inside the loop increments I but then assigns I to the old value. So this statement might confuse a lot of students. They will think, okay, we are increment the value of I and we are assigning the value of I, so I value keeps on incrementing. But can you please see what is happening with this plus plus? This plus plus is a postfix increment operator. What happens in a postfix increment operator? In a postfix increment operator, the operation is done first and then the value is incremented. So what is the operation in this case? The assignment operation. So 0 is assigned first to I and then it gets incremented. So every time the same value is assigned to the value of I, so I equals to 0 doesn't change. That is why 0 less than 10 is the condition all the time. That is why it just goes into an infinite loop and it doesn't terminate, right? Okay, so let's see this question, and it's a very simple question and the answer for this question is D basically. Okay, so the line 4 generates a possible loss of precision compiler error. Line 4, this one, this particular line, right? The cast operator has the highest precedence, right? So what happens is that it is evaluated first, so it casts it to a byte. Okay, then the addition is evaluated, causing both A and B to be promoted to int values. Cool, following till now? Then the value there is 90, right? For 50 plus 48 is 90. The value is an int and cannot be assigned to the byte sum without an explicit cast. So the code does not compile, because we are trying to cast it to A to an byte. If we do this thing, then it will not throw an compiler error, right? That is why the code will not compile because of this line, because it is automatically promoted to an int and we cannot store an int in a byte, right? Because byte is smaller than int, and so on and so on. Going to 11, the answer is pretty simple. Answer is A, which is 2. Why is that? Very simple question. The into or the multiplication and the percentile have the same operator precedence, so the operation is evaluated from left to right in this manner, right? So the result of 5 into 4 is 20 and 20 modulus 3 is 2. Very simple. So the remainder is 2, right? Obviously 2 into 6 18 and we have 20 minus 18, which is 2. That's why the answer is 2. Sometimes, in the exam also you get very easy questions, so don't panic. You will also get your fair share of easy questions. Not all the questions in the exam are very difficult. Let's go. What is the output of this following code snippet? This is actually a very simple question also. Let us try to figure out what is the answer. Try to do it on your own. The answer for this question is D. Code will not compile because of line number 5. Pretty simple to understand, right? So why is that? The variable x is an int and s is a reference to a string object or S is a string type. That is why we cannot compare X and S, right? That is why the code doesn't compile at all, right? Due to line number 5. Let's see this question number 13, right? Very easy to understand, guys. Very easy to understand, very easy to answer if you know the concepts. Now, in this particular question, the answer, please try to pause and try to answer it on your own. Okay. Now, the answer for this question is A, which is the success. Why is it the answer? Let us try to discuss about it. The code compiles successfully. There is no issues in the code compilation. And so the options C and D are incorrect. So these two options are basically incorrect. Don't worry about that. The value of B after line 4 is false. What I am saying, the value of B after line 4 is false, right? Because this is false basically. So what happens in this case? What happens in this case? If the value of B after line 4 is false, the if then statement on the line number 5, what it does is basically B equals to true. Even though the B is false over here, we are just reassigning it to true. So this entire expression becomes true and we are printing success on the screen. Sometimes, and it happens very often, that people get confused with the single equal to and double equal to because they are in a hurry. Please don't be in a hurry, guys. Please understand that the examiners try to trick you a lot with the equals to and double equals to operators. So don't fall for that trick. A lot of people fall for that trick. And a lot of questions actually come around that also. Let's go to question number 14. This is also a very simple question. The answer to this question is C, which is 12. Let us understand how this is the case. The code compiles successfully. So there is no issues with the code's options. So basically, sorry, my bad. So the code compiles successfully in this case. So there is no, so we can just discard the F option that we have over here. So on line number 5, what happens? What happens on line number 5? The pre-increment operator is used. So C is incremented to 4. The C variable that you are seeing is incremented to 4 first, because obviously the pre-increment has the highest precedence in this case. And the new value is returned to the expression. The value of result is computed by adding 4 to the original value of 8. That is why the answer is 12. So what does this expression actually means is that we have result equals to result plus C. Result plus C. So what happens? First plus C happens and then it is being added to the result. Cool. Simple as that. Result value is 4 and it becomes 8. 8 plus 4 is 12. Pretty simple question. Let's go to question number 15. And this is actually a very simple question, guys. It's a very simple question. Answer to this question is E. The code will not, क्या हो गया मेरे पेन को? The code will not compile because of line number 4. It's a very simple question, guys. Just try to imagine why it is very simple. The while statement on line 4 is missing parenthesis. That's it. That's the only thing. Remember that even though you can use shortcuts, you cannot omit the parenthesis of your for, your loop, your while, your do while, or your if or else, like that. Else if, whatever. You have to use the parenthesis. This is not Python, guys. This is Java. So don't joke around like this. And sometimes this question may come in the exam, and if you just know good about the syntaxes, you will be able to answer this question. Let us go to 16. 16 is also a very simple question, guys. Answer to this question is D. Code will not compile because of line number 6. Why is the case that code doesn't compile? A lot of question comes where the code doesn't compile. You have to figure it out. It's really frustrating, but you need to answer it like that way. So what happens over here is that the variable y is declared within the body of the do while statement, right? So it is out of the scope on line number 6. That's it, right? Very simple. Let's go to 17. What about 17? Kind of a little bit difficult, but still it is a simple case, right? The answer of this question is basically D. Array, my pen is not working. Oh, what happened to my pen, man? Oh, now it is working. Answer is D. Code compiles without issue. So F is incorrect. F, we shouldn't even consider F in this case because code compiles. One technique I'm going to tell you guys. Before actually evaluating your output, check if the code compiles or not, because in the first two line itself there may be some code which makes the code doesn't compile, or in the last two lines. Try to check if the code compiles or not. Once you figure out that the code compiles successfully, then there will be one or two options which says the code doesn't compile. You just discard those options directly. Don't even consider those options and waste your time. First step is to check that if the code compiles or not, and then once the code compiles, then please go for the output. Now let us discuss this. D. So compiles without an issue. So F is incorrect. After the first execution of the loop, I is decremented to 9. If we keep a track of I, so I was 9 at first. I was 10 at first, and then I is decremented to 9, right? That is how this loop goes. If you see the thing, and result to 13, because result minus 2 is happening. So result was 15 and then it has been reduced to 13 in this case. Since I is not 8, right? I is not 8. So what happens? Keep going is false. Since I is not 8, keep going is false, and the loop continues to run, right? So what happens in this case? On the next iteration, I is decremented to 8. I becomes 8 in this case. I is decremented to 8. Result is decremented to what? Result is decremented to I is 8. Result is decremented to 11, right? Result is decremented to 11. On the second execution, I does equal to 8, so keep going is set to false. Okay, at the conclusion of the loop terminates, since keep going is no longer true, right? So as keep going is no longer true, the value of result is 11, because at the last time when we saw, the value of result was 11. So we are just going to print the value of result, which is 11. I think I made a mistake when I said that I was 9 and keep going was false. At that time keep going was true only. When I becomes 8, keep going becomes false, because this condition evaluates to true. So keep going becomes false. Okay, let's see this question. Pretty simple question, and the answer to this question is A, which is 1. Let us try to understand how it is 1. The expression on line number 6, right? Just try to see this particular expression, line number 6 expression. Is true when row into column is an even number. That's what it is checking. Row into column, modulus 2 equals to 0. On the first iteration, row equals to 1 and column equals to 1. So the expression on line number 6 is false. No issues. The continue is skipped, right? The continue is not executed. And count is incremented to 1. So we can just say count equals to 1 now. Now because count plus plus is happening in that case. On the second iteration, row equals to 1 and column equals to 2. So column becomes 2 in this case. So the expression on line number 6 is true, and continue ends the outer loop with count still at 1. Now let us go to the third iteration. On the third iteration, row equals to 2. So row equals to 2 and column equals to 1. So that's what outer loop, inner loop, outer loop, inner loop. That's how it is happening, right? Row equals to 2, column equals to 1. So the expression on line number 6 is true in this case. Expression on line number 6 is true in this case, and the continue ends the outer loop and count is still at 1. So count is not changing. Just keep a track of the count. On the fourth iteration, row equals to 3 and column equals to 1. Right? So the expression on line number 6 is false, continue is skipped, and count is finally incremented to 2 now. Finally, on the fifth and the final iteration, right, row equals to 3 and column equals to 2. Right? So the expression on line number 6 is true, and the continue ends the outer loop and count is still at 2. So finally, the result of 2 is displayed, and the answer is not A, answer is B, guys. Answer is B, my bad. I just my mistake, I just thought it was 2, and I just after calculating the output, sometimes your eyes open and you just see, okay, I got the wrong answer. The answer is 2, so answer is B, my bad. Okay guys, now let us go to 19th question. 19th question. So answer in this case is D. Let us understand why. Prior to the first iteration, m equals to 9 and n equals to 1. When you are solving these output questions, always write it down first. Then you can do it in your mind when you are comfortable with it. So let us write 9 in a proper way. M equals to 9, n equals to 1, and x equals to 0. X equals to 0. After the iteration of the first loop, m is updated to 8. What is happening? M minus minus is happening, right? And m greater than n, which is true. So m is updated to 8. M minus minus is happening, and n is updated to what? 3, right? N plus 2, right? N is updated to 3. X, what happens to x? Now x is basically added to the sum of the new values for m plus n. So 0 plus 11. So 8 plus 3, 11, and x value was 0. 0 plus 11 equals to 11. So x value is what? 11. Right? So x becomes what? X becomes 11. Cool. Now, after the iteration of the second loop, m is updated to 7. And what has happened to n? N is been updated to what? 5. Yes, correct. If you have answered 5, then it is 5. And x to the sum of the new values, which is basically what? 23. Cool. M is updated to 6. N is updated to what? 7. X 23 plus 13, which is 36. Now this condition becomes what? False, because 6 is not equals to 7, right? And we can just write it like this. I don't know why I wrote it like that. My bad. 6 is not equals to 7, and also it is not greater than 7. So that is why we just come out of the loop and we just print 36, which is the value of x. Pretty simple. Last question, guys. Try to answer this question. Very easy question. Answer is B, which is great, good. The code compiles and runs without an issue. So options C, D and E are incorrect. So we just discard these 3 options entirely. We just have to select between A and B. The value of grade is B, and there is a matching case statement that will cause grade to be printed. And this is I'm going to give a hint. It is basically a case of fall through effect. There is no break statement after the case, though the next case statement will be reached or executed, right? So good will be printed. So great good will be the answer. And in the case C, we have a break, so it breaks at this particular case. So great good is the answer. That's it for this particular chapter, guys, and these were some of the questions which you may get from this particular chapter. Now we are going to go to chapter number 3 from our next video, and let me just give you a summary of chapter number 3. We are going to learn about core Java APIs. We are going to see some APIs of Java which may come in the exam. So we are going to continue with chapter number 3 from the next video or from our next lecture. Till then, have a nice day. We are going to meet in the next video. Till then, bye bye.